Welcome to Intermediate Algebra, Chapter 2, Section 3, where we're going to talk about equations of a line. And the first form for the equation of a line I want to talk to you about is slope-intercept form. Some of us call it y equals mx plus b form. And in this format, the value m is going to tell us what the slope of our line is, and b is going to tell us not just the intercept, but more specifically what the y-intercept of our line is, where the graph of our line is crossing the y-axis. And we're going to go through and look at some examples here. The first one, y equals 2/3 x plus 7. The slope is being identified for us as 2/3, and the y-intercept says 0, 7. So those are the actual xy coordinates of the y-intercept. From the origin, we move horizontally 0 units, and vertically we move up 7 units, and so we would have a y-intercept at 0, a y-intercept at 0, 7. I'm distracted because my cat is outside of my office door meowing her tiny head off, and so that threw me. In our next example, we're asked to find the slope and y-intercept of this line, and this is not too difficult of a task to master pretty quickly. We can safely say that m equals 1/4 is the slope of our line, and the y-intercept in this case is located at 0, -7. So remember, the slope-intercept form is behind my head. There it is. Y equals mx plus b. And that plus b, we have to be careful there, because if it says minus, we have to realize that what we're really doing is adding a negative number. So there, our b value can be more clearly seen as a -7. In number 2, the slope of our line is +3, and it's the coefficient in front of our x variable. So m is 3, and you notice that nothing is being added or subtracted after our x term. Therefore, our b value is a 0. So our y-intercept is located at 0, 0. So this line is passing through the origin. And in number 3, as is often the case, our math problem here is made more difficult by requiring us to do some additional steps that have been added onto the beginning of the process. So what we're going to do is take this equation and we're going to convert it into y equals mx plus b form, and then we will very easily be able to identify our slope and our intercept, our y-intercept. So let's try to leave the y value exactly where it is, and I'm going to subtract 2x from both sides. I put a little note over here about what I'm doing to both sides of my equation. You could write minus 2x under here and minus 2x over here, but as you can see, that takes up a whole extra line, and I don't have a lot of real estate to work with sometimes, so I devised this other notation where I just put a note in the margin about what I'm doing to both sides of my equation. That leaves me with a -5y on the left-hand side, and I'm going to do something that maybe you wouldn't think to do initially, but instead of writing 9 minus 2x on the right-hand side of my equation, I'm going to put the -2x first, and then my +9 after it. And that way it's already more closely mimicking the format that I'm trying to achieve, y equals mx plus b. Then let's divide both sides by -5. That will cancel out the -5 in front of my 5y, or in front of my y. Actually, this one, let's write it out. -5y divided by -5, and on the right-hand side, I'm going to distribute my division right away. I could have written it as all over -5, but instead of doing that, I'm going to divide my 2x by -5 and my positive 9 by -5. Am I allowed to do that? Yes. Do I have to do that? Not always. But in this case, do I want to distribute my division to both of those terms instead of just leaving it as one giant denominator? In this case, yes, we want to do that. And I will show you why. On the left-hand side, the -5's cancel, leaving us just with a y. On the right-hand side, these negatives here are going to cancel. And the 2/5 is now positive, and instead of keeping the x up here in the numerator, I'm going to write the x next to my fraction. Am I allowed to do that? Yes, because my x is really still over 1, so that x is still in the numerator. We just sort of let it slip down next to the fraction a little bit, because this m value, which represents the slope, is now a fractional or rational coefficient. It tells me how much x I have, in a way. Over here we have a positive 9 divided by a -5. Positive divided by a negative is a negative, so I will write that as subtraction, and then put our 9/5. So this isn't our answer, but with our line written in this format, it makes it much easier to identify the slope and the y-intercept. Our slope here is going to be positive 2/5, and the y-intercept is located at 0, negative 9/5. The y-intercept at 0, negative 9/5. I'll take just a moment to remind you, or point out to you, maybe this isn't a reminder. If you want to put a little note in your notes, you should know that negative 9/5 is equivalent to negative 9 over 5 and positive 9 over -5. This fraction could be written in any one of those three ways. When it's a coefficient like a slope, it's very often written with that negative sign sort of in line with the fraction bar, but it could be moved around to the top or the bottom if for some reason that makes more sense based on what's going on in the question. Number 4 now asks us to graph this given equation, which is in slope-intercept form, using the slope and the y-intercept. That language is important because if you're entering your answer for this graph, if you're doing this graph in your online homework learning management system, whichever one it is, the software is looking for one of the points that you click on to actually be the y-intercept. I could definitely graph this line for you on a computer by clicking on 2 points other than the y-intercept, but here, make sure that one of the points you click on is the y-intercept. In this case, our y-intercept is located at 0, 3, so that's the first point that I'll plot. From the origin, horizontally 0, vertically 3, and then I'm going to use the slope in order to graph another point. Now my slope, m, here is 1/2, which is rise over run. So we could start at this point, which is our y-intercept, and we could rise 1 unit. So we would go up 1 unit in the positive y direction, and then we will run or move horizontally positive 2 units. So let's do that. Let's go up 1 and over 2, and we'll land at this other point. And we could definitely draw ourselves a line through that point right away. Another thing that you should realize, which very seldom, but every once in a while this comes in handy, you won't be surprised to hear that this is equal to -1 over -2. Normally we cancel out those negative signs, but every once in a while it makes sense. Instead of going up 1 and right 2, maybe you want to go down 1 and left 2. We end up at this point here that I put in green. And you'll notice, if I can get my digital pen to work with my manual straight edge. Those 3 points are still on the same line, and looking very Christmassy, I might add. That was unintentional. So a couple of different ways that you could get the correct graph to appear, but be mindful that either way, when you're clicking on points in order to graph this online, one of the points you click on should be your Y-intercept. The next question asks us to graph this equation using the slope and the Y-intercept yet again. This equation, however, is not in y equals mx plus b form, so it's not extremely, that's not very helpful, right? It doesn't sort of start us off in the right direction. So you now have seen an example of how to go through converting an equation like this one into y equals mx plus b form, slope-intercept form, and you've seen an example of how to take an equation that is already in slope-intercept form and graph that equation by using the slope and the y-intercept. So take those two ideas, put them together, those two processes, put them together, and you should be able to graph an equation that is given to you in this standard format. Number 6 asks us if these two lines are parallel, perpendicular, or neither, which gives me the opportunity to tell you about how to determine if two equations are parallel, perpendicular, or neither. And to make that determination, you want to know the slope of both of your lines. So line number 2 here, we have a little bit of work to do. We need to convert this to slope-intercept form so that we can find out the slope. So let's do that. I'm going to add, I'm done with green. Let's try purple. Here we go. Let's add 2x to both sides. I'm going to leave that 7y right where it is. Now on the left-hand side, I only have the 7y. On the right-hand side, I'm going to put the 2x first. It's positive. The 4 stays positive. And then let's divide both sides by 7 to isolate that y value. Dividing by 7. And if you want to write the 7s underneath all 3 of these terms, that's a good idea. The 7s will cancel in front of the y, leaving me with y equals, and then I like to write it as 2/7 with the x next to it, and then plus the 4/7. Now in this particular problem, that we're not concerned with the 4/7. What I'm concerned with is that the slope of line 2 is 2/7, and the slope of line 1, right there, is also positive 2/7. So the answer to this particular question is my two lines are parallel. How did I know that? You might be able to infer two lines are parallel if their slopes are the same. So you should be writing that in your notes right now. Parallel lines have the same slope. Or if you say that backwards, if they have the same slope, they're parallel. How am I supposed to know if two lines are perpendicular? Perpendicular lines have opposite, if I can write, opposite reciprocal slopes. For example, now just bear with me 1 second. In line number 1, I highlighted that the slope was 2/7. So I would call that M1, slope 1. And in line number 2, it had a slope. Let's call that M2. Well, in this separate example, let's say that M1 was equal to 3/5. What would M2 need to be in order for line number 2 to be perpendicular to line number 1? What is the opposite reciprocal of 3/5? And the answer is If we flip this fraction over, making it 5/3, and then we change the sign, that's why it says opposite reciprocals, a line with a slope of -5/3 would be perpendicular to a line with a slope of +3/5. Another example. What if your original line, or your first line, had a slope of 4? What's the opposite reciprocal of 4? The reciprocal is 1/4, and the opposite would make it negative. What if the 4 had started off as a negative number itself? Then slope number 2 would be positive. So they need to have opposite signs and be reciprocals of each other. Those are, or that would be an indication that you're working with perpendicular lines. If your slopes aren't the same and your slopes are not opposite reciprocals, then you are not looking at lines that are perpendicular or parallel, so you would answer that they are neither. Our next question wants us to use slope-intercept form to find an equation of a line with slope 5 that passes through those 2 points. Using slope-intercept to do that. You could do this, but I wouldn't recommend it. You could do it, but my preference would be for you to use the point slope formula. So I'm going to skip over that previous example and introduce you, perhaps for the first time, probably not, to point slope formula, or point slope form, which says y minus y1 equals m times x minus x1. And the time to use this form for the equation of a line is if you are being given the slope of the line and the coordinates for a point on the line. The slope that you're being given would be m, and the point on the line that you already know would be the values x1 and y1. For example, in number 8, use the point slope formula to find the equation of a line having a slope of 2. See, there's your m value. And passing through the point 3, -5. There's your x1, y1. So all you have to do is take those 3 numbers and plug them into point slope form, and that's your answer. At least that's your answer in point slope form. You could then convert that into slope-intercept form, and we'll do an example of that right now. Number 9 says, or asks us to find the equation of a line passing through this point that's parallel to 7/3. And we want to write the answer in slope-intercept form. So we'll design our equation for our line, and then we'll make the conversion. If you want, you could label this as x1, y1. And our new line is going to be parallel to this line. This line has a slope of 7/3, so what will be the slope of our new line that's parallel to this one? Remember that parallel lines have the same slope, so our new slope will be also positive 7/3. So we could just put down a note maybe that m equals 7/3. All right, let's plug these values into point slope form. I'll leave it on screen there. There you go. So we have y minus our y1 value, which, be careful, is -2, equals m, which is 7/3, times the quantity x minus x1, which is a positive 2. You'll notice that I put my x value and my y value into my formula, or my function, not my function, into my formula. using parentheses. And the time when that's really beneficial is if you happen to end up with a double negative. It won't look like one really long choppy subtraction sign or something. You're less likely to get confused as you're looking at your own handwriting. Some of us obviously have better handwriting than others. Alright, so what am I doing with this thing now? I'm supposed to write my answer in slope-intercept form. For starters, I'm going to simplify on the left-hand side, and I will distribute on the right-hand side. DIST for distribute. The simplification on my left-hand side leaves me with y plus 2 equals, and when I distribute on the right-hand side, I get 7/3 x minus 14/3. Now I got 14/3 because when I looked at the number 2 right over here, I didn't just see it as a 2, but I saw it as a 2 over 1. And when I multiply fractions like 7/3 times 2 over 1, the 7 times 2 made the 14, and the 3 times the 1 made the 3 in the denominator. We're almost there. We need to subtract the 2 from the left-hand side so that y is all alone or isolated. But I don't want to think, well, we could do that, but I'm noticing that on the right-hand side, I have to deal with these denominators of 3. So my common denominator between this 2 right here and the negative 14/3, the common denominator is going to be 3. So I think what I'll do is, if you have a little bit of room here like I do, maybe you want to cross out the 2 and write it as 6/3. 6 divided by 3 equals 2. The other thing that you could do is put a little note next to the 2 that you're going to be multiplying it by 3 over 3. And if you think of this as a 2 over 1, 2 times 3 makes 6, and the 3 times the 1 makes a 3, and you've got your 6/3 again. So that's how I came up with that 6/3. I really actually like the sort of technique or the thought process of thinking of it as a fraction times a fraction. So now we have y plus 6/3 equals 7/3 x minus 14/3. And now we can subtract the 6/3 from both sides of our equation, leaving us with a final answer of y equals 7/3 x minus 20/3. This is a great example of a problem where you would not want to try to switch over and work it with decimals. I know that some of you, when you have a denominator of 2 or a denominator of 4, it's easy for you to convert those into 0.5s or 0.25 or 0.75, but especially when you're working with thirds or sevenths or sixths, those decimals are going to get really ugly, and I highly recommend that you force yourself to get better at manipulating these fractions. It's going to save you some time and effort down the road. What's the slope of this line that we've just created? Look at that number in front of the x. Our slope is 7/3. And what are the coordinates of our y-intercept? Since we're on the y-axis, we have an x-coordinate of 0 and a y value of negative 20/3. Sometimes you have to click on a point. Like if you had to graph this line, the first point you'd have to click on would be 0, negative 20/3. Maybe converting negative 20/3 into a mixed number at that point instead of an improper fraction, that might be a good idea. Negative 20/3 is 8 2/3. Well, negative 8 2/3. Is that true? No, it's not. How about negative 6 2/3? There we go. That's a little bit easier to find on the y-axis. You might think, well, how am I supposed to do that accurately? Don't worry about it. Most of the online learning management systems are designed with some error tolerance. So as long as you're pretty close to -2/3, below 6, you should be just fine and your software should accept that as a correct answer. And the last thing that we see here is a table of forms for the equations of a line. Standard form has your C value over on the right-hand side. That's your constant value. I've even seen it where the C value was subtracted over to the left-hand side and only a 0 remained on the right-hand side. That's a possibility. This is a good reminder that horizontal lines have a very specific format of y equals, as opposed to, or in contrast to, a vertical line, which is going to have an equation that starts with x equals some number. And then finally, we just saw slope-intercept form and point-slope form. My hope is that that gives you a really good start on homework problems and refreshing your knowledge about the equations of lines, and I look forward to seeing you in the next section. See you there.